Let's take a look at the homework for lesson 611. So the first one says, what if you've got two solutions? The first one's got 2 moles of solute dissolved in 8 liters of solution. The second one is 6 moles of glucose in only 4 liters of solution. So which one's more concentrated? Well, I can do the math on this, but it's pretty obvious that the second one is more concentrated because it's got more solute dissolved in every 1 liter of solution. More concentrated, and we can say more solute for every 1 liter of solution. Okay, what would the concentration be for number 2 if you've got 3.5 moles of sodium chloride dissolved in 5 liters? Well, the way to calculate molarity is to take moles divided by liters. So in this one, they had it set up pretty nicely for us. We can just divide the 2 numbers, and I get 0.7 molar. To be thorough, I should include my chemical, sodium chloride. Let's take a look at this blood sugar question. If you measure a sample of blood, it says they found that there were 30 grams of glucose for every 800 milliliters of blood. So let's figure out what this person's blood sugar concentration is. Well, first, we've got to get grams of sugar into moles of sugar. So I've got to figure out the molar mass of C6H12O6 using the periodic table. So I'm going to add up 6 carbons, 12 hydrogens, 6 oxygens. 1 mole weighs 180.18 grams, about. So that means I've got 0.17 moles of C6H12O6. And the way I did that was I multiplied across the top 30 times 1 divided by the molar mass, 180.18. But I'm not done. 800 milliliters of blood, if I divide that by 1,000, I can convert it into liters, and that converts into 0.8 liters. Now I can do the math. 0.17 moles divided by 0.8 liters, that comes out to be 0.21 molar. So this is way above the normal sugar levels. I hope that's not an actual human sample. Number 4, how many moles of sucrose does 25 milliliters of 0.2 molar sucrose solution contain? Oh goodness, this looks like a lot at first, but we can use our handy dandy molarity triangle to help us out. If I want to solve for moles, I'm going to ultimately need to take molarity and multiply by my liters. So this makes sense because the capital M stands for moles per liter. So if I've got a 0.2 moles per liter solution and I've got 0.025 liters of it, I had to divide by 1,000 to get milliliters into liters here. Then when I multiply, I get 0.005 moles of sucrose. Part B says, how many grams is that? So 0.005 moles of C12H22O11. I've got to figure out, well, how much does 1 mole weigh? And I don't even have close to 1 mole, so I'm going to be multiplying by that fraction amount, 0.005. So I've got to add this up from the periodic table, and it adds to 342.34 grams. Multiply across the top, divide by the bottom, I get 1.71 grams of sucrose. You've probably heard of the blood alcohol content legal amount allowed when you're driving. and it's 0.08. That means 0.08 grams of ethanol for every 100 milliliters of blood. So let's figure out what the concentration is. So again, in all these problems, if you've got grams, since we're talking about molarity, we're going to have to convert grams into moles. You could pretty much just bet on that. So I've got to figure out how much does 1 mole of C2H5OH weigh. And so I've got to add up 2 carbons, 6 hydrogens, 1 oxygen. It adds to 46.08 grams. Multiply across the top, divide by the bottom. I'm talking 0.0017 moles of ethanol. And that's in every 100 milliliters of blood. So I've got to divide by 1,000 to get milliliters into liters. That's 0.1 liters. So now I can do my moles divided by liters, and I get 0.017. That is the concentration of ethanol in your blood that you're allowed to still drive with. Number 6, what about if you're looking for milliliters? How many milliliters of a 4 molar solution can be made if you've got 0.05 moles of lithium bromide? Well, if you think about this, what we're really wondering about is 0.05 moles divided by what is going to make a 4 molar solution. So once we swap those two, we're really taking 0.05 moles divided by 4 molar, and we're finding out that that's 0.0125 liters. So what is that in milliliters? We need to multiply by 1,000, and it comes out to be 12.5. And the last question asks you to do a little research on what exactly happens to salt when it dissolves in water. And this brings back the polarity of water. You might remember the intermolecular forces where we talked about how water is extremely polar because oxygen is so electronegative. It's so greedy compared to hydrogen. So what happens when you put an innocent little salt molecule into water is it gets ripped apart because the bond, the ionic bond that was held together by those attractive forces, now the sodium gets pulled to hang out near the oxygen, and the chlorines get pulled to hang out near the hydrogen. And so what you end up seeing is a whole bunch of these ions that are separated. And now we can see right through that solution. Salt water is clear because the sodium and chloride atoms are not together anymore. They got pulled apart, ripped apart by the water molecules. So hopefully that helped you to figure out that